Hello, today I'll be coding this animation. If you can't tell, that's a tetrahedron which gets rectified. This means we cut out its corners. Its corners are also tetrahedra. What's left in the middle, it's an octahedron. So I've split this into frames and I've picked out the colors and they're already in the CSS. So let's get started with the structure. So here we're going to have a 3D assembly, and within it we're going to have the 4 tetrahedra and the octahedron in the middle. So here we're going to have a mixin, and this creates a 3D shape, a regular 3D shape, a regular polyhedron. So here we're going to have n, which is the number of faces. And here we're going to have the 3D shape and shape 3D, and we're going to have a second class, and this one depends on the number of faces. So shape 3D, and here we're going to interpolate that number n, and here we're going to loop, and we're going to create the 2D faces. Okay, now that we've done this, we have a different number of faces for the tetrahedron and for the octahedron. In the case of the tetrahedron, this number also happens to be the number of vertices. In the case of the octahedron, this is not true. We have 8 faces, but only 6 vertices. This also makes the octahedron the dual of the cube, which has 6 faces and 8 vertices. So here we're going to have a loop. And in here, in order for this particular demo, we're also going to have a 3D positioner. So 3D positioner, and here we're going to call this mixin, and we're going to use the number of faces for a tetrahedron. And at the end of the loop, we're going to call the mixin again, and we're going to create the octahedron in this case. Okay, so this should give us the shape we want. So let's see. This looks fine. Okay. Okay. I did something wrong there. So the octahedron has 8 faces. Okay, good thing I caught that. Now we're going to start with the edge length of one of the 3D faces. So both the octahedron and the tetrahedron have the same edge length, and we're going to set this to something like 25 viewport minimum units. Something should work. Now we're going to have, for a triangle, we're going to have 3 vertices and 3 edges. And we're also going to have a base central angle corresponding to every edge, which is 360 degrees over the number of edges. Next, we're going to compute the circumradius of the triangle, and this is going to be half the edge length over sine of half that base angle. Now that we've computed this, we can also have the in radius, and this is pretty much the same, except here we have tangent. And I always find it very funny, the syntax highlighting here. Probably thinks it's the color 10 or something. I don't know. So this is going to be twice the radius, so twice the circumradius. Okay, I can collapse this for now, and I can collapse that HTML. And now let's move on to the 2D faces. We're going to set some dimensions. So width is going to be that diameter, and we're going to have the same value for the height. So let's change this to height, and we're going to set a background. This is going to be current color. So this should do it. Now one thing I want to do here is set position absolute. So position absolute. So okay, this does it. But my faces are triangular, so let's create triangles. We're going to have a mixin, a regular polygon mixin. So regular polygon, and this is going to take n vertices, which is also going to mean n edges, and the default is going to be that number, the number for a triangle, and it's going to take a circumradius, and by default this is going to be 50%, but it can be any value in any units. That's why we're going to use calc in this mixin. And here we're going to have a list of points, which is empty initially. Then we're going to have a base angle, which is 360 degrees over the number of edges. And now we're going to have a loop. So for I from 0 all the way up to n, we're going to have that the current angle is the index, the loop index, times the base angle. Then we're going to have the x-coordinate, and this is going to be calc. And since everything is relative to the midpoint, which is the 50% point, we're going to add everything up to that one. And here we interpolate the circumradius times cosine of the current angle. And we're going to have pretty much the same for the y-coordinate, except, this is going to be y, not x. And here we're not going to have cosine, we're going to have sine. And finally, we're going to update the list of points. So we're going to take its previous version, and we're going to add these x, y coordinates. Finally, after the loop, we're going to set clip path, polygon, and we're going to use that list of points. Alright, now that I've done this, I'm going to take this regular polygon mixin, and I'm going to include it here. So include regular polygon. And as you can see, I have a triangle, but I don't want it to point towards the right. So the first vertex in this case is the vertex here at 3 o'clock. And I want the first vertex to be at 12 o'clock. This means that I need to go back by 90 degrees. So that's an offset of minus 90 degrees. So I'm going to have an offset angle of minus 90 degrees. So here I'm going to need to make this change. I'm going to add this offset angle. And now I'm going to have the triangle pointing up. Okay, but I don't want it to be solid. I only want the edges. So what I'm going to do is I'm going to use the zero width tunnel method again. And I'm going to have a relative radius here. And let's say this one is going to be 0.05, something like that. And here I'm going to compute a second radius. And this one is going to be 1 minus that relative radius times, times the circumradius. Now one more thing I'm going to have here is another inner list. And here I'm going to take these 4 lines and I'm just going to copy paste them with a few changes. So here I'm going to have minus because I go the other way. Here I'm going to have the second radius. And here I'm going to add to the inner list, not to the points list. So now that I've done this, here I'm going to have the points list is going to be join the points list and the inner list. Sorry, like this. Okay, so this should do it. And one more thing here, this is going to be through. So this gives me what I wanted. Now, the next thing that I'm going to do is put everything in the middle. So the assembly, this is going to be top 50%, left 50%. And now the top left corner of this 2D shape is at 50%, 50%. So I'm going to set a negative margin by half its dimensions. And half its dimension is the circumradius. So that's going to put it right in the middle. Now, one more thing I'm going to do here is for all 3D elements, so I'm going to have class contains 3D. I'm going to make sure they can have 3D transform children. So that's going to be transform style, preserve 3D, because otherwise their 3D transform children would get flattened into their own plane, into the plane of their 3D transformed parent, something like that. Okay, now that I've done this, I'm going to set a transform here. And using this transform, I'm going to position the faces on the I'm going to position these 2D faces on both the tetrahedron and the octahedron. So I'm going to have first a rotate Y, then I'm going to have a rotate X, then I'm going to have a translate Z. So first of all, the rotate Y. This is going to be a calc value, and this is going to make the whole thing only work in WebKit browsers, because other browsers don't support calc inside rotate. So here I'm going to have a J index, and this is going to be times, now here I'm going to need an angle, and I'm going to copy paste this for the polygon width for edges and for vertices. Same thing. The regular polygon with 4 vertices and 4 edges is the square. So here I'm going to just replace everything, all 3's with 4's. Here included as well. So I'm going to take this angle, and this is the angle I'm going to use, because this is the angle I rotate them by. This is because the octahedron can be taken as two square pyramids with common base, and the tetrahedron can be taken as being the intersection of the diagonal planes of a cube. So yeah, now I need to interpolate that value. Okay, and here I'm also going to have a calc value, and this is going to be a rotation around the x-axis, which is going to be the same for all faces of a tetrahedron, the same for all faces of an octahedron, but different between the two shapes. And here I'm going to have another value, another index value, and again, the defaults for both of these are going to be 0, and this is going to be times half a turn. This is because half of the faces of an octahedron point up and half point down. And the same thing for the tetrahedron if I take it as being inside a cube. And here I'm just going to have a Z offset, which is a custom property. And again, same value for all faces of a tetrahedron, same value for all faces of an octahedron, different between the two shapes. Now what I'm going to do is set that J value. So I'm going to have for J from 1 to the number that goes around. Okay, and then I'm going to have nth child so this is the number of edges of the section of a tetrahedron, of the diagonal section of a tetrahedron. So n plus, and here I'm going to have j plus 1, and I'm going to set the custom property to this loop value j. Okay, now that I've done this, I can collapse everything here. I'm not going to need it anymore. And here I'm going to add an animation. Animation, let's say 28 seconds, linear, infinite. And I'm going to have this animation. So I'm going to have keyframes, and it's going to be, let's say, 100%. Transform, rotate x, 1 turn, and then I'm going to have pretty much the same, except it's going to be not x but y. Okay, now that I've done this, the thing rotates all around, and I should start computing stuff. So here I'm going to compute one more thing, and this is going to be the height of a triangle, and this is going to be the circumradius plus the in radius. Now I'm going to start computing things relative to the 3D shapes. So the number of faces for a tetrahedron is going to be 4. Then I can compute the dihedral angle, because the cosine of the dihedral angle is the in radius over the height of a lateral face. And now I take the arc function and this returns a value in radians, so I convert to degrees, 180 over pi. Now, the rotation around the x-axis for this shape, for this 3D shape, is going to be minus half this diagonal angle. And then I'm going to need to compute the in radius of the 3D shape. And this one is going to be the circumradius of the lateral face, which is a triangle, over the tangent of the diagonal angle. And now I'm going to pretty much copy paste this and make the needed changes. So what I'm going to do is just have 8 there. Oops, sorry, not there as well. And here I'm going to have something pretty much similar. I'm going to compute directly this angle right here. Let's get rid of that. And this is going to be the arc sine. And this is going to be the in radius. So the base in this case is going to be a square. Okay, so this does it. And here I'm going to have times the in radius over the height of the lateral face. So this should do it and should give me what I've been after. So now I'm going to set, this is going to be not x, this is going to be z, sorry. And it's going to be pretty much the same for the tetrahedron, except of course 4 instead of 8. Now things don't look right yet, and this is because I need to change that I value. So for the even ones, so nth child to n, I'm going to have that I isn't 0 anymore, so it's 1. Now I'm going to do something similar here, except it's not going to be 2n. It's going to be the second half. So the second half of the faces of the tetrahedron. So that's going to be n plus. And here I'm going to have half the number of faces of a tetrahedron plus 1. So this is how I get the tetrahedron, and you can see the tetrahedron there. Okay, now next thing that I need to do is position those small tetrahedra onto the faces of the octahedron so that I can create the bigger tetrahedron. So I'm going to have the 3D positioner, position 3D, and I don't think I can do this directly. So what I'm going to do is I'm going to have a mix in here. So I'm going to have mix in position, and I'm going to have a horizontal offset and a vertical offset. And then I'm going to have here transform, translate 3D, and I'm going to have values for x, y, z. So x, y, z. Okay, and all 3 of them are going to be calc values. So I'm going to have here a multiplier. So this is going to be, there's going to be a vertical multiplier and a horizontal multiplier. I don't know what else to call them. Okay, and this is going to take x and z are horizontal, so horizontal offset, and y is vertical offset. So this is going to be vertical offset here, and it's only going to depend on the vertical multiplier and not the same way. So this is going to be twice this vertical multiplier, minus 1. And for the z, I'm going to have something similar to the x, except here it's going to be 1 minus. Now I'm going to set defaults here. So the horizontal by default is going to be -1. The vertical by default is going to be 0. And here I'm going to include position. And it's going to take the horizontal is going to take the in radius, and the vertical is going to take half the circumradius. So this should do it. Okay, and this positioned 1, but I need to do all the others. So what I'm going to have is, for the even ones and child 2n, I'm going to have that the horizontal multiplier is 1. So this should add 1 more. Okay, this looks good. And then I'm going to have, for the second half, nth child n plus half the number of faces of a tetrahedron, which is also equal to the number of corners. So that's 0.5 times plus 1 there, because I need to take starting with the first and the second half, and the vertical multiplier is going to become 1. So now that I've done this, I have the whole big tetrahedron. Okay, now I'm just going to take this animation out of there, and I'm just going to have a transform, rotate x 90 degrees, and I'm done with the assembly. So I have that nice shape right there. Okay, now I can collapse this mixin as well. I'm going to set an animation duration, t, and this is going to be 5 seconds. Next, I'm going to have a percent value. Let's say it's going to be 10% or something like that. And then I'm going to have an offset animation. So I'm going to have some offset keyframes. So keyframes D for distance, offset, stuff like that. I'm going to have 2 include position, which is pretty much the same, except it's going to be double. So twice So now that I'm going to set this animation, so D, that's time t, it's going to be is in infinite alternate. So this looks good. Okay, now I'm going to take this. Now I'm going to add an animation here. This is going to be the rotation, and it's going to be twice, and it's not going to be alternate. It's going to be is in out as well. And I'm going to have something similar. So here I'm going to have 0% and that percentage P, and this is going to be 0 degrees. And here it's going to be 100% minus that P. Then I'm going to have something similar for the color. So I'm going to have this white, and this is going to be something like this. So here I'm going to have a second animation. So it's going to be color T, linear, infinite, alternate. So yeah, this is pretty much it. You can find a link to the CodePen demo in the description below, and if you have any questions, you can drop them in the comments or send them on Twitter. I hope you've enjoyed this video, and if you have and you want me to be able to do more in the future, please consider supporting my work in one of the ways explained in the description, with a donation, by getting me something off my Amazon wishlist, or at least by sharing this to show the world what can be done with CSS these days, because I think it's pretty damn cool. In any event, thanks for watching.